Alright, in this video today we're going to be talking about relations and functions and how they work together. So the first thing that we need to talk about is what is a relation. I think about relationship when I think about the word relation in math. And a relation is basically the pairing of input and output values. So when we're talking about a relation, we're talking about the pairing of input and output values. So input values are going to be your x values, and your output values are going to be your y values. So nothing special other than the fact that if I have an x, then I have a y. It's a pairing of the two. There's no significant relationship that is special. We'll talk about that in a second. If there's something special going on, it's just the pairing of an x value to a y value. Now, another key word that you need to know is domain. So domain is my input values. So my input values are my x values. So when you think about domain, you should be thinking about the x values. My range is my output values. So my range is the same thing as talking about my y values. Now, when we look at it, talk about a function is a special type of relationship. So a special type of relation. Okay? And the reason it's special is because it has to follow a certain criteria. So in order to be a function, you can only have each input has to have exactly one output. So it is a special relation which each input has exactly one output. Now, I'm going to kind of shorten this down for you and make it super simple. When I think about function, a function has no repeating x values. Because if I have repeating x values, then it's no longer has exactly one input for one output. And we're going to look at that several times today. Now, the other thing is, you're going to probably have this question asked quite a bit as we go through. A relation can be a function. A relation, okay, can be a function, but a relation is not always a function. So a relation is not always a function, but a function is always a relation. Because a function is a special type of relationship. So when I think about a function, I think about it, the function is a more detailed name, and the relation is the general name. Kind of like if I call myself a girl, okay, but I then call myself Lindsay, or Miss Kirk, that means that my general relation, my general name is girl, and then my function, my special name, which is my detailed name, is going to be Miss Kirk. So again, a relation can be a function, but it's not always a function. But a function is always a relation, okay? Now, we're going to look at three types of ways to look at functions today and relations. We're going to look at order pairs. So order pairs are where we have an x and a y. We're going to look at it in a table. Same thing, I have an x and a y. I'm going to look at it in a graph, so I'm going to plot my points, and we're going to do some mapping. Now, the important thing to know about mapping is that when I map, I always map from left to right. So my left side, the arrow is always going to the right side. So that tells me what maps from left to right. Now, I always like to turn everything into a table myself. So with an ordered pair, it's kind of already in a table format. But let's say I have a graph. So if I have a graph, then I'm going to take and I'm going to identify my points. So I have -2, -2. Then I have -2, +2. Then I have 0, 1. And 3, 1. All right, or with a map. this -2 maps to -2, but this -2 also maps to +2. So that makes 2 points there. So this is -2, -2, -2, +2. The 0 maps to 1, and the 3 maps to 1. And I'm kind of running out of room over here, so I'll just kind of put it beside it. Now what we're going to talk about are these relations that I've talked about with an order pair, a table, a graph, or a map, are those functions, okay? So the next thing we're going to look at is we're going to talk about some mapping. So in my mapping, I just said a second ago that it's going to be a lot easier to handle a mapping situation and determine if it's a function if you write it as a table. So when I look at this, I see that -2 maps to -1, because remember that arrow is going left to right. -1 maps to 0, 3 maps to 0, and 6 maps to 4. So is this a function? And explain. So how do I know if it's a function? I cannot have any repeating x values. My x values do not repeat. Now, do I have a repeating y value? I do. I have a repeating y value of 0, but that's okay. The only thing that cannot repeat are my x values. So this relation is the function for A because each input maps exactly onto exactly one output. So no repeating x values. So that is a function. All right, let's look at the next map. All right, so I have -2 is going to map to -2. I have 1 to 0. I have 2 to 2, but 2 also maps to 3. Now, since I have two 2's, this is where this is going to change, and this is not going to be a function. This is a relationship because I have an x to a y, but it is not a special type of relationship because I have repeating x values. And because I have repeating x values, this relation is not a function because the output 2, or excuse me, the input 2 is mapped to 2 and 3. So it repeats itself. No repeating x values in order to be a function. All right, so then we have the same thing with the order pair. Again, you can look at it and you can identify your key pieces. I just like to look at it in a table. I just feel like it's more organized. You don't have to do that. So I have -5, 2, -3, -1, 0, 0, 0, 2, and 0, 5. So is this a function? This is not a function, and I have repeating x values. So basically I can say that 0 maps to 0, 2, and 5, and that makes it repeat itself, and that's not a function. This is a relation, but it's not a function. All right, so how do we look at it graphically? So graphically, we're going to do what we call the vertical line test. So the vertical line test is a relation is a function if and only if no vertical line, so when I draw a vertical line, it will only intersect the graph at one point and one point only. So if I'm looking, so you see they kind of drew a line here. It intersects at that one point. I could draw another line. It intersects at one point. It doesn't matter where I draw my vertical line, anywhere on that graph, it is only going to hit it at one point. So therefore, this is a function. Why is it a function? Because there's only going to be one x value to hit that graph every time. All right, so let's look at the next one. This is the reason this is not a function. Here's their line. It hits it twice. So because it hits it twice, that means I have repeating x values. I could do it again. I could draw another line in a different location. It's going to hit it twice. So in order to pass the vertical line test, it can only hit the graph once if a vertical line is drawn. If a vertical line is drawn and it hits more than once, then it is not a function. Okay, because if it hits it more than once, then it's got repeating x values. All right, so another example. If I have this circle graph, this is not a function, and the reason it's not a function is because I can intersect it twice. So this is not a function. All right. Another option here. If I have a line. Now this line is diagonal, so it's going to be a little bit different for us here, but it still doesn't matter. If I draw a vertical line, it's never going to intersect that graph more than one time, no matter how many vertical lines I draw. So this is a function. Okay. So let's look at some examples. And it says, are these graphs a function, and explain. So these graphs are not connected. These are just plotted points, but it doesn't matter where I graph my vertical line, it never hits the points more than one time. So it hits here, 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 but it doesn't hit it any points more than once. So for this particular example, we can say that this graph does represent a function because no vertical line intersects the graph at more than one point. Okay, so if I were to draw a vertical line over this whole problem, which I did, it will never hit more than one point. All right, so if I look at B, do you see a point that if I drew a vertical line, it would hit more than one? And I see a couple of them actually. So it would hit here and here. And I see another one that would hit the x value at 1, 2, 3, 4, 5, 6. So 6 and 3 are both repeating x values. So for B, because it hits more than one point, the graph does not represent a function. And the reason it doesn't is because the vertical line at 3 and 6 intersects at more than one point. All right, so a couple more examples. If I look at these two examples here, is the first one a function? The first one is not a function because if I draw a vertical line, it intersects that graph twice. So this is not a function because it does not pass the vertical line test. All right, is the next one a function? The next one is a function because no matter where I draw a vertical line, it will never hit the graph more than one point. So this one is a function. Okay. All right, so let's look at a few more situations here. It says graph the following points and determine if the relation is a function. And honestly, we don't have to graph these. We can just look at the situation here. So remember, in order to be a function, no repeating x values. So I have 8, 4, 8, and -5. So I have repeating x values here. I have an 8 and an 8. So this is not a function, and it's not a function because I have repeating 8 values. All right, the only other thing that I may do is I may draw a map here that I can represent for my problem. So I know that I have 8 for an x, I have 4, I have 8 again, and I have -5. So you don't need to repeat those values. I have 0, 6, -2, and 7. So when I draw this, I'm going to make sure I draw them from left to right. So 8 will map to 0. 4 will map to 6. 8 will also map to -2. And -5 will map to 7. So one of the things that I always look for is I always look for a value that has 2 arrows going to the right. If those 2 arrows are going to the right, then it's not a function. All right, so let's look at another one. So we're actually going to map it this time again. All right, so I have -1 for my x, 0, 4, and I have 0 again. So then I have 2, 3, I have 3 twice, and then I have 5. So let's map our pieces. So -1 is going to go to 2, 0 is going to go to 3, 4 is going to go to 3, and 0 is going to go to 5. Now, is this a function? The answer to that is no, because 0 repeats itself. I have 2 arrows going off of 0, so this is not a function. It's a relation, just like any other thing that we map any x to any y, but it is not a function. Remember, a function is a special relationship. All right, so my pages kind of got messed up here, but I'm asking you for the domain and the range. So what we're going to do is I'm actually going to write it on this side. And if I'm looking at the domain and the range here, so remember the domain is all my x values. So we use the squiggly brackets, they're called sets, to list those, and we list them from least to greatest. So we're going to go -1, and we're going to list 0 twice because that's part of the domain, and 4. For my range, again, we're going to do a set bracket. So we're going to do the y values now. So least to greatest, we have 2, we have 3 twice, and we have 5. All right, so another one on this side. Let's do another mapping. This is the last one we're going to do. So we have, for my x values, we have -2, 7, -3, 12. And for my y, we have 4, 1, 5, and 1. So we're going to map these. So -2 is going to go to 4, 7 is going to go to 1, -3 to 5, and 12 to 1. So this particular problem is a function. And it is a function because I don't have any repeating x values. So if I'm talking about my domain, remember my domain are my x values. So we're going to put them in my sets from least to greatest. So we're going to do -3, -2, 7, and 12. And then for my range, from least to greatest, I'm going to do 1. I'm going to repeat that twice, 4, and 5. All right, so just a reminder to kind of summarize, a relation just simply is when I have an x and a y that are paired together. A function is a special type of relationship, and that special relationship is when I have no repeating x values. The domain is x values, the range is y values. And when I'm talking about a actual graph, I can use the vertical line test to see if that graph is a function. Hope this video helps. If you have any more questions, please let us know.